Okay, this is going to be the Trig video, lesson 4. Okay, we're now going to get into the radian component of the unit circle. I've got my special right triangles up here. I want to draw a big, I want to draw a big unit circle here. And let's put the stuff in we already know. Okay, all right. We already know this is 0, 360. We already know this is 90. We already know that this is 180. And we already know that this is 270. Okay. We talked about this being quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In those quadrants, we talked about all being positive here. We talked about just sine and cosecant being positive here. We talked about tan and cotan being positive here. And we talked about cosine and secant being positive here. Okay, last class we also talked about the concept that the things were on these points. Okay, so this would be, if we were doing sine, cosine, and tangent, that would be 0, 1, and 0. 0, 1, and 0. Flipping it over here, all that did when we went to this side was SCT, is this would be 0, negative 1, and 0. Okay, when we were here, all right, if we were ever at the 90 part for SC and T, we would be 1, 0, and undefined. And then if we went to here, okay, all right, and we were sine, cosine, tangent, we were negative 1, 0, and undefined, okay? All right, that's what we covered so far. Now we want to introduce the concept of radians. To a certain degree, the radians are actually easier, okay? Now, we learned that we converted, this is going to be pi over 6, this will be pi over 4, and this will be pi over 3, okay? So, in essence, what you have here is in this quadrant, you have pi over 6, pi over 4, and pi over 3, okay? If you were to, and if we were in a normal class setting, we would go and convert all of those other ones to radians. But what you're going to find out is, all right, you're going to have 5 pi over 6, 3 pi over 4, and 2 pi over 3. In this quadrant, you'll have 7 pi over 6, 5 pi over 4, and 4 pi over 3. Okay? In this quadrant, you're going to end up having 11 pi over 6, okay? 7 pi over 4, and 5 pi over 3, okay? Now, the big thing for you to be able to do is that all you have to do is look at the bottom number of your fraction, and that takes you to the appropriate triangle. For instance, if I asked you, I want you to find the cosine of 5 pi over 4. Say, Mr. Evans, do I have to make that into a degree? No. All you got to do, since it's a 4, that means it's got to be this triangle here, okay? All of them go back to that triangle. So I would do that as a over h, okay, which is square root of 2 over 2, okay? Now, the big thing you got to figure out is where is it, okay? Let me give you a little trick for figuring that out. It's easy when it's just these. That's quad 1, okay? If you look at these, okay, notice how all of these numbers are 1 away, but they're all less than 1 because this is going to be 1 pi. This is going to be pi over 2. This is going to be 3 pi over 2. And this is going to be 2 pi, okay? All right, so the idea here is that these numbers are less than 1, okay? If you look at these, notice how it's 7, 6, 5 fourths. The difference there is 1, okay? But these numbers are slightly bigger than 1, okay? So, all right, the challenge for this, I would say, of all these things is these ones, okay? They're clearly more than one number apart, okay? So 11 and 6 more, 7 and 4 more. Now, if you go old school fractions, okay, they're also, if you divided 11 by 6, it only goes in one time. If you divided 4 by 7, it only goes in one time. And if you divided 3 by 5, it only goes in one time. So it's still less than 2. So that's the way you know. If your fraction ever goes in more than 2, we'll talk about that in a little bit. Okay? So, all right, you got to figure out what quadrant you're going to be in. So you're going to get all the same types of questions. You'll also get them where they're on the axis point. Okay? All right, so let's go ahead and we're going to, let me duplicate this, edit and duplicate. Okay? Let me go to the second page. All right, I want you guys to have your unit circle out. Okay? I want you to have your unit circle out because I will not be able to show, all right, every unit circle here. Okay? All right, so let me go ahead. I'm going to delete these things. All right, let's go through just a bunch of random questions, maybe 8 or 9, just to get an idea of what we're doing. Okay, all right. So let's say I wanted to find the secant of 5 pi, or sine of 5 pi over 4. Let's say I wanted the cosine of 2 pi over 3. Let's say I wanted the tangent of 11 pi over 6. Let's say I wanted the cosecant of let's do 5 pi over 6. Let's say the secant of 7 pi over 4. Let's say, so that should be 4, 5, 6. Okay, and then let's do cotangent of 4 pi over 3. Let's do sine of 3 pi over 2. Let's do secant of pi, and let's do cotangent of, let's say pi over 2. Okay, so here's our problems here. Okay, we're going to work all our way through it. Okay, so we got to figure out which, we should already know which triangles they already tie back to. Okay, all right, so this is O over H. Okay, all right, so this is the 4 triangle. So this would be, opposite would be square root of 2 over 2. Okay, so the big thing we have to figure out is what quadrant are they going to be in? All right, well, I'll even draw a mini one. We know that pi 6, pi 3, pi 4. That's easy. Okay, all right, the 6th one, it's going to be slightly less than 1. So 5/6, slightly less than 1 2/3, slightly less than 1 pi 3 pi over 4. Okay, all right, this will be slightly greater than 1, 7 pi over 6. Okay, the 4 pi over 3. All right, and the 5 pi over 4. All right, I know these are only 1 apart. That's how simple that is. Okay, all right, and then the other ones we sort of got to figure out whether it's less than 1. Okay, so 5 pi over 4 would be this quadrant. Only thing positive would be tan and cotan, so that'd be negative square root of 2 over 2. This one ties to this triangle, so that's A over H for that triangle. The A is going to be 1, the H is going to be 2. Okay, 2 pi over 3, that's going to be this triangle. Only thing positive are sine and cosecant, so that'd be negative 1/2. 11 pi over 6, this is the only thing I got to check. How many times would 6 go into there? 1. Okay, so that means that's got to be down into this quadrant here. Okay, so the 6th triangle is this one. Tangent is 1 over the square root of 3, which we know turns into square root of 3 over 3. Since I would be in this quadrant, only thing would be positive would be cosine and secant, so that would be that. All right, cosecant of 5 pi over 6. Automatically know it ties to this one. All right, cosecant is H over O, which would be 2 over 1, which my result here would be 2. Okay, what quadrant am I in? I'm in this quadrant. Only thing positive, that's actually going to be positive in quad 2. So I'm good there. All right, 7 pi over 4. Okay, that ties back to this triangle. Okay, so H over A, which is 2 over square root of 2, which we know will turn into square root of 2. Okay, now all I got to think about is what quadrant is that in. It could be that one, okay? How many times does that go in? 4 goes into 7 once, so it's got to be that one, okay? So the only thing positive is cosecant and secant, which would be, give me that, okay? 4 pi over 3. That 3 is going to tie back to that. Cotangent is a over o, so that's going to be 1 over square root of 3, which is square root of 3 over 3. And this, and 4/3 would be in that quadrant. Tangent would be, and cotangent would be positive, so I got those, okay? 3 pi over 2. That's going to be, this will be on that line. So that's just going to be, I'm going to look at that, that's going to be -1, okay? All right, secant would be on this one. Cosine there is 1, so this would also stay 1, okay? All right, 1 pi over 2, that's going to be right there, okay? Tangent is undefined there, but since we're looking at cotangent, we'd flip that, and that would give me 0, okay? All right, so what I'd like you guys to do, okay, let's see if I can duplicate this. Edit and duplicate. Am I bored a second? Okay, great. Wonderful. Let's see if that's page 3. I think it is. All right. All right, so let's go to 3. All right, let's erase some of these. Okay, I'll try not to duplicate any of them to the best of my ability. No promises. Let's go, I would like you to find sine 5 pi over 3, cosine 3 pi over 4, hopefully that's not a repeat, it is not. Let's go tangent 7 pi over 6. Cosecant of let's do 7 pi over 4. Let's do secant of 5/6. Let's do cotangent of 2/3. Let's do cosine of 3 pi over 2. Let's do cosecant of pi. Let's do tangent of pi over 2. Okay? All right, so go ahead and pause your video and go ahead and work on those. Okay, go ahead and unpause. Okay, 5 pi over 3. Okay, I automatically know it's going to be that one. Okay, so O over H. All right, for that one would be square root of 3 over 2. Okay, what quadrant is it in? Well, I know it's not, the difference isn't 1, so it's got to be 4 or I got to do something else. It only goes in one time, so it's in quad 4, so that's going to end up making that negative. Okay, cosine there, that's going to trace back to this, so A over H. Okay, so square root of 2 over 2. Okay, that is going to be in this quadrant, quadrant 2, which would make that negative. Okay, tangent 7 pi over 6. It's going to trace back to that. So tangent's going to be O over A, or 1 over the square root of 3, which we know will turn into square root of 3 over 3. This will be in this quadrant, which would keep that being positive. Okay, 7 pi over 4. That's going to lead to that one, which is H over O, which would be 2 over the square root of 2, which we know that's going to be square root of 2. This one will be in this quadrant, okay, because this only goes in one time, so that's going to end up being negative square root of 2. Okay, all right, secant 5 pi over 6 traces back to that triangle, which would be h over a, which would be 2 over the square root of 3, which we know will be 2 square root of 3 over 3. That will be this area, so that would be negative, okay? Cotangent of 2 pi over 3, it's going to be in that quadrant. 3 would trace to that, so it's going to be a over o, or 1 over the square root of 3, which would be square root of 3 over 3. And since it's in this quadrant, it would be negative, okay? All right, on this one, this would be here. If I look at my chart, I see that that's 0. For this one, that would be here. I see that sine will be 0, so what would cosecant be? That would have to be undefined, okay? Tangent of pi over 2, tangent of pi over 2 is here, and if I look at my chart, that's also going to be undefined, okay? All right, let's see if I have one more duplicated one. Okay, let's go over a couple of more examples. Let's say I have, they want me to find cosecant of negative 5 pi over 4, and then let's say we get another one. Let's say 2 pi over 3 plus 2 would be 2 pi over 3 plus 3, which should be. Let's say we wanted to find secant of 8 pi over 3. Okay, so, all right, these are very much the same as the other ones, okay? All right, the only problem is I got a negative, all right? So what I'm going to do, just like the last time, I'm going to add 2 pi, which is really 360, okay, to make it positive, all right? So from a common denominator standpoint, that's negative 5 pi over 4. I would need to multiply this top and bottom, which would be 8 pi over 4. Which would, if I add that, would be 3 pi over 4. All right, so that's what I'm working with. That's going to be the 45-degree triangle. Okay, all right. Cosecant would be h over o, so that'd be this would be 2 square root of 2. So it's going to be 2 over the square root of 2, which would turn into square root of 2. Okay. Now 3 pi over 4 ends up being in this quadrant. This would end up being positive, so that's going to be my answer. Okay. So what you have to do is basically get a common denominator and add them there, okay? Now this one, you know, the thing would be, oh, that's got to be quadrant 4. The problem is, how many times does 3 go into that? 2. So that is, it goes in more than 2, so I'm going to have to subtract by 2 pi, okay? So once again, you get a common denominator. I'm going to have to multiply by 3, so that's going to be 6 pi over 3. If I subtract that, that's 2 pi over 3, okay? All right, once again, that's in this quadrant, okay? The 3 triangle will be the 60, so square root of 3, 2 and 1, all right? Secant is h over a, so 2 over 1, which would be 2. In this quadrant, sine and cosecant are the only thing positive, so that's what I would get with that. So what you have to do is, if negatives are easy, you know you have to add 2 pi. What you have to check, if you think it might be too big, is how many times does this go in? If it's more than 2, I got to subtract by 2 pi, okay? So let me just give you 2 questions. I'm not going to overdraw that for you. Let's say I got cotangent of, let's say, negative pi over 6. And let's go sine of... let's do 13 pi over 4. Okay, so go ahead and pause your video and then go ahead and work on those. Okay, go ahead and unpause. So what I have to do here is I have to add 2 pi. So I'd have to make this a common denominator, so that's negative pi over 6 plus 12 pi over 6, which is 11 pi over 6, which would put me in this quadrant, okay? All right, which is the only thing positive there is going to be cosine and secant, so this is going to be negative, okay? So my 6 triangle will be the 30-degree one, okay, HO and A, all right? So So cotan would be A over O, square root of 3 over 1, which would be square root of 3. Since it's in here, only cosine would be positive, so that would be negative there. Okay, this could be quad 4, but I have checked. How many times does that go into? It goes in 3, so I gotta have to do something. I have to subtract 2 pi. Once again, getting a common denominator, that's gonna be 3 pi over 4 minus 8 pi over 4, which would be 5 pi over 4, which would put me in this quadrant here. Okay, only thing that's going to be there is the tan one is going to be tan and cotan. So we know that our result here is going to be negative. Okay, so this would be the 45-degree triangle. Okay, H, O, and A. Tangent, square root of 2 over square root of 2 would just be 1. So my answer there is negative 1. Okay, so that gives you, that's the whole unit circle. That's all your radians. All right, all the degrees have been covered. Okay, we'll get into some applications now in the next couple lessons.